Hello, everyone. Thanks for coming to my talk. Appreciate it. So I'm Hari. I'm going to talk about how we went on this journey about uncovering about 100K violations, and it's going to be a bit of a case study, and also about talking about how we realized SBOM was really important, and also probably touch upon a bit of about how we leveraged AI in the DevSecOps workflows. Now that I look at this title, it's probably really too long, but yeah, I should have probably renamed it something like Raiders of the SBOM or something like that. But anyway, moving on to the next slide. Yeah, so I'm Hari. I've had the privilege of working at multiple places like AMD, Athena Health, and Bain. Feel free to connect with me on LinkedIn. Also check out my GitHub. So for the agenda today, I've split it into like 5 parts. First really telling about the problem statement and the challenges. Then giving an overview about like what unified deployment model is all about and how it actually helped us in solving the various challenges that we faced. And then switching into automated complaints and SBOM generation. And then I guess if I don't talk about AI, this talk wouldn't be complete. So definitely we're going to talk about how we leveraged NLP and AI in our pipelines, and then possibly leaving you with some strong takeaways and future directions. So talking about the problem set, one of the organizations I'd worked previously, we had about, it was going through this tech modernization journey, right? So the idea was to ensure that there was a centralized platform to create infrastructure so that we reduce the burden on developers. And at the same time, there is increased governance that is also set in place. And there was also this journey of like trying to save costs. In terms of overall deployments and unifying them so that there's larger visibility and observability, right? And for that, they try to go into this multi-cloud hybrid solution, which sort of like served their needs. But then the first thing when you talk about like costs is you wonder like what are the trade-offs, right? So like okay, where am I trying to cut corners? So because there were 2 work streams that were happening in parallel. One, there were software teams that were trying to build out features and ship them out the door so that they can actually attract more customers and increase the overall market share. On the other hand, there was also this wide work stream of like really caring about this unification of deployments and really implementing the hybrid cloud solution perfectly. And the first thing was like, okay, do we really have to care about security in the first place while we're doing all this? So this journey was also about like trying to make security as a first-class citizen, and at the same time, ensuring it's not an afterthought, right? So let's go to the next slide. Yeah, so this is a sample graph about how the various deployments were within the company. There were several in-house deployments. There were some teams were working on ECS deployments, some teams were working on EKS deployments. So it was sort of mostly fragmented. There was no unified way to scan for vulnerabilities across the organization. Pretty much not a lot of visibility into even costs and what was happening and so on and so forth. So from an organization perspective, we wanted to do 3 things. One, we wanted to shift the security all the way to the left so that we really empower the developers as well and not burden them. Second is we wanted to also make our CI/CD pipelines more intelligent, for lack of a better word. And then the third one was we wanted to ensure that the developer teams, the incident management teams, the DevSecOps teams all collaborate to each other so that a culture of caring about security was inculcated across the organization. So yes, I think I sort of like set up for this slide as to why security was important. So this is all the setup for that. So that's what we're going to talk about. So I think the next few slides are going to really talk about like why security is really important and why we should actually care about it. It's sort of like, say, a quick pocket of time of going back to the basics, and then we'll switch back into how we actually implemented it. So if you look at the entire software development lifecycle, we have, after you actually like create your code and then push it out, you create your packages, then you promote them, distribute them, deploy them, and actually run them, right? One major takeaway for us as developers was we were extensively using third-party open source packages wherever we wanted, right? So the large takeaway from that was the entire attack surface was maximized. Any part of the software supply chain could definitely be exploited. So one thing that, so as I said, we really understood that anything that the software supply chain or the security begins from anything that enters the SEC and then ends in production. It's like an end-to-end. So when we wanted to implement the security workflows, we ensured that we sort of impregnate all those little boxes so that each of those workflows cared about it. Oh, and then another thing I also wanted to mention was before this, right, we only found out about vulnerabilities after we actually deployed stuff, or rather after it actually went live, right? So sometimes, like for example, a few years back about the Log4j issue when it happened, we were like, oh, it actually happened now. Okay, we gotta go fix stuff. We got to go remove all the packets that we probably are vulnerable right now, and then so that we reduce the blast radius and then fix things. So this was also pivot and actually figuring out the vulnerabilities much in advance, so that we also care about. We started caring about metrics like mean time to detect, mean time to remediate, and so on. So this was the first step in the right direction, I should say. Oh, and then I think the previous two talks as well, they touched upon this topic, which is very interesting for me as I was hearing them, which was, so once we started using all these tools that told us about oh, this is a CV you should care about, this CV is really high and so on, we realized that not all CVs are actually exploitable. Very frequently used packages, like if you take in Python, if you take the requests package, or if you take the curl package, there are an insane number of CVs reported on them every day. And then a few days later, they would be like, oh no, you actually don't need to care about the CV anymore, right? So that was also a learning experience for us. So not all CVs are actually exploitable, and we really had to figure out which CVs you should care about. Another thing from the previous talk, which I also had a large takeaway, was when you actually peruse through the various CVs, when you're having environments, multi-cloud environments, and you have to, and when there is let's say there is a CV that has a huge score and has a high attack vulnerability, when it has a high attack vulnerability, the level of exploitation is very context specific. So we needed to start care about oh, is this CV going to affect this distro or not? Is it going to affect this distro or not? Say, is it going to affect the Apache project? Is it going to affect the Linux distro or the Ubuntu distro? So we had to be really specific when dealing with large scale CVs, very really high scores. And then this is a quick slide telling you about how many CVs are reported every month. It's drastically increasing, and then there's a constant pressure on teams and also developers to go fix stuff, because after a point, I think for some high profile projects, we actually set up Git hooks to ensure if they don't actually go fix it, you can't actually merge and deploy stuff. So to what can we do better? We can definitely educate ourselves and ensure that we don't always rely on open source packages a lot blindly, and we manage permissions, set up the right rules, and continuously optimize, and then course correct ourselves as we use packages. Oh, so this was, I think this was worthy of a slide, which was as developers, when we work on shipping features, we actually don't document all our dependencies really well. So in fact, if you look at the slide deck, in this slide, there'll be two swim lanes, which basically says that you have to broadcast what your actual microservice actually depends on. So that was something that we had to do a better job at. So we declare dependencies, write code, and then declare more dependencies which we would need, and then before you actually build and run the code and deploy it. Because half the time, I think there was a fun on a quick side note, sidebar. There was a fun project which we did where we wrote some scripts to actually construct a directed acyclic graph in terms of figuring out what are the various dependencies in terms of packages, and then we realized that there were so many dependencies we were not even accounting for, or we never cared about. And they were like, oh, okay, this actually existed, okay. And then we went back and documented those dependencies. So that was a fun project which we did in Python, but that's when we realized this slide was pretty important, where we have to actually like really know about what the microservice that we're shipping really depends upon. So yeah, so now that all that preamble has been said in terms of like why we had to care about security, so this is about how we implemented security, like what the unified deployment model was all about. Just doing a quick time check. Yeah, so yeah, this is a big diagram, but I'll sort of like summarize this diagram. So one, we had to make like some strong decisions, which was, we said that, okay, at this particular timeline, everybody's deploying to EKS. So some teams didn't like it, some teams liked it, but it was like, we got to move to EKS. So if you look at this diagram over here, oh, I guess I can see the diagram here too. So if you can look at this diagram, the developer checks in the code, and then Jenkins has a webhook, it picks up and then does a CI build, and then it pushes the build to a particular container registry. We set up appropriate webhooks in the container registry to ensure that the build information for that repository is actually like pushed and an SBOM is generated. We'll talk more about SBOM and what it really does, but SBOM is software bill of materials and gets generated. And with that SBOM, there is another webhook listener to a deployment orchestrator that is a separate microservice that runs. And the deployment orchestrator, first, before it actually deploys something, it goes and runs some set of rules for compliance to see if it actually passes those rules, to actually validate if it can proceed for the deployment. And then it pushes the Kubernetes manifest to a GitOps repository. And then we have EKS clusters in place, which constantly sync with the GitOps repository and listen to see if they can actually proceed the deployment. And depending on the type of deployment or the infrastructure, we had like controllers in place, like a Terraform controller or a Kubernetes controller and so on. I wish the diagram could have been bigger, but yeah, thanks. So this framework, we ensured that this was cloud provider agnostic, so that this can be applied to, say, AWS, Azure, or any other cloud provider, so on. But the directional shift was everybody's moving to AKS. At least we had to take the strong call so that everybody comes onto the same platform, and then so the large takeaways was everybody comes onto the same platform, everybody generates a build information, every deployment generates an SBOM, and every deployment goes through a set of compliance checks. So this is how our journey began. Oh, so this is about pretty much okay. So when we decided to use tools for the container registry, we had to do a lot of pick and choose, right? We had a lot of options for what container registry we wanted to use, or what compliance check vendor we wanted to use. What is the CI/CD? Where is the CI/CD pipelines going to be hosted? So we had a lot of options. When we went about those options, we decided on a particular vendor, and we were like, so that the idea was all the developers use the same tool. We didn't want to ensure that we pick and choose different tools, so that that becomes a whole learning by itself, wherein we have to foster trust by setting up workshops for all the developers. That would be a journey by itself. So we picked and chose strategically so that all the tools work well with each other, and then there was automated complaints in SBOM that were generated. And in fact, one of the tools that we also picked, it ensured that it gave like IDE plugins that developers could install, and as they coded, it would actually inform them if the code base, if they're introducing new vulnerabilities to the code that they're adding, which is the screenshot on the next slide. So as the developer is coding, it gives you a view of like, oh, are you really causing the CV or not? And it also, these advisories also do a really, really good job in telling you if it is a software bug, or if it's a backdoor, or if it is actually malicious payload code that is actually like that you have inherited right now. So that sort of differentiation definitely gives a lot of insights. Okay. Oh yes, so I actually want to talk a bit about SBOM and how it actually helped us. Just moving on to that slide into my notes section. So the one anomaly whenever I talk about SBOM, which I always remember, is like having a slice of cake. And when we introduced SBOM to our organization, there were like so many questions, because one of the organizations I worked was fairly regulated. It was a regulated industry, and they had like strict guidelines. So I thought I'd probably also touch upon some of the questions that they did ask, like in terms of like why we should care about SBOM and what it's all about. So the first analogy that I remember whenever I think about the word SBOM is it's like a slice of cake. Like there are several layers. Then each layer can have different ingredients. They can all be sourced from different places, and they can all be delivered differently. So SBOM, so when you tie in a software bill of materials to an actual software product, it tells you like all the various ingredients that go into the software, and right from environmental variables, proprietary information, any whether it's open source packages, and so on and so forth. So the one thing I wanted to touch upon is when there are three stakeholders for an SBOM, right? So when you produce software, people care about what goes into building and maintaining the software, and they also care about the various upstream components that go into the software. People who purchase software, right, not produce it, SBOM can give you like pre-purchase assurance. It can give you can even like negotiate discounts based on SBOM. And there are people who operate software. So people who operate software, they care about vulnerabilities. They care about maintenance. They also care about licensing and the overall supply chain flow too. So that all sparked like interesting conversations like at probably like the C-suite level and things like that when we started really like automating SBOM for every deployment that like for example if you take like you could have like 100K like say 150 deployments per day, and when each deployment generates an SBOM, then the insights from those SBOMs can be pretty revealing. Oh, so the three things I also wanted to touch upon is one of the questions that was asked is can SBOMs be a roadmap to an attacker? So if an SBOM, somebody gets an SBOM, can somebody actually attack you? Not typically. Like so SBOM generally gives you all the ingredients, but doesn't really tell you like how they are used. It doesn't give you the recipe to it. So not really. It's more of a defense for people who want to protect their product rather than who want to exploit it. And people who generally try to exploit do it through they have other means to exploit your packages if they really want to. And another question which I also wanted to touch upon is which was asked in the at the org level was would there be IP infringements in case of like somebody actually gets to know your SBOM? Again, it just gives you the ingredients but not really telling you about like how the recipe is actually used. So yeah, so while all this was happening, there was another parallel effort which I was part of, which was how we could use AI and NLP in DevSecOps pipelines. Like, and then when we went up on this journey, we realized that so whatever we spoke about before, like how we had to care about security even when AI was not in the game or was not a player, we probably have to care more about it right now. So I thought I thought it would make a lot of sense including this piece as part of my slide deck, and I think I wouldn't earn my badge without this. So yeah, so this diagram is very similar to the previous one, but then the only difference is that we front-loaded that workflow with a REST API agent that could respond to NLP queries. So you have a REST API agent that gets like NLP queries, and then the REST API agent forwards it to like different LLMs of interest, and then those LLMs would take care of deploying infrastructure. So this was done sort of to reduce the overall time it takes to actually deploy a service. So this was a separate work stream that was also happening. Yeah, so this diagram is very similar to the previous one. There's no difference except for the front loading of the REST API service. So the objective behind this was we wanted to really find out like which LLM model really works for us, what's the human versus LLM generation time for deploying a service, and do LLMs need domain-specific training? So we created a data set. We also uploaded on Hugging Face, which essentially is about like some of the example queries are make a VM in US East 1 or US West 2, or deploy an EC2 instance with S3 bucket storage, or like you could also have like a complicated query where you spin up an EKS cluster, set up like read replicas and so on, right? So on and so forth. The slide has slightly different examples, but I think you get the picture. So we did some benchmarkings. We used the most widely used ones like GPT, Llama, T4, and so on, and we realized that some worked well than the others, but these graphs are included for fun. but the larger takeaway is that we could pretty much use LLMs to generate like infrastructure as we needed, and there was an overall like 73% reduction time in terms of like the time it took to actually deploy a service with using LLMs rather than without. So yeah, so it took like someone like me or someone like another engineer like 100 minutes to set up a complicated setup, whereas an NLP system could do it in like 27 minutes or 30 minutes. But then there are always like exceptions to the rule where you have like really advanced use cases where you have to set up a system, and then the NLP system needs a lot more context and needs to be trained much more. Yeah, so we also took this up on an opportunity to actually present it in an IEEE conference regarding the various findings about how we could use LLMs in DevSecOps pipelines. So feel free to check out the paper, or happy if you cite me as well. Yeah, so while we did this, these are some interesting things which we also learned, which I also thought of sharing as we were going through this journey of like really caring about security from an org level. So we deal with like models, like this is a sort of like a misnomer. It is called totally harmless model, but really does mess up with your system, which is which can be really a malicious package, right? And then people have become really innovative in terms of like how they want to affect your system when you actually start using LLMs. So this seems to be like a super legitimate model, but then when you actually look into the code, it really affects your system because the actual vulnerability is hidden in the binary data, right? Just doing a quick time check, yeah. And on the other hand, this is a very interesting flow for me, right? So when there are a lot of people who actually do a lot of like vibe coding actively, like reach out to LLMs and then keep asking questions and sort of like build things really fast. So what attackers nowadays are doing is they really sort of try to figure out like what people are working on, and if you ask they publish packages with similar names to what people are looking for, which can contain malicious code, and sometimes the LLMs hallucinate and give you the names of those packages, and then you install them, and then the product that you're trying to build has a backdoor or a malicious code to it, which was a very interesting way of injecting malicious packages into, say, PyPy or Nexus or any of those public repositories. And yeah, so LLMs also are not great at generating secure code, as we see. Like even if you ask it to generate secure code, they had challenges. So in terms of future directions, as I touched upon, we wanted to ensure that we do some domain-specific fine-tuning so that the LLMs are more context-aware, and so that we, as an organization, are able to use it to actually not just speed up deployments, but also care about security at every level, and should handle complex queries. And we also wanted to, the experimentation that we did, or was just focused on deploying infrastructure, but not on like actual product development. So not sure how that extends to that yet, but something that we need to figure out. Yeah, so I thought we'll finish with a meme where one does not simply end a security talk without SBOM and AI. But I'm happy to connect with everyone later, and hope this talk resonated with you. And there's a lot to learn. And at the same time, thanks for listening to my entire talk on surviving all the 100K violations that we spoke about. Thanks. Yeah, go ahead.
What was the name of the paper?
It was as long as my title, but it was optimizing service deployments with NLP, and yeah, it was pretty long. Hold on a second. Yeah, I can go back to the slide deck. I actually probably have it. Oh, I just have the name where I presented it. Give me a second. Yeah, the full title of that is optimizing service deployments. Excuse me? Yeah, optimizing service deployments with NLP-based infrastructure code generation and automation framework. Yeah. Yeah, thanks. Oh, sorry, go ahead.
For SBOM generation, are you using SIFT or another tool?
We were using another tool. One thing I can also talk about that is we ensured that the SBOMs are generated in both formats, like Cyclone DX and SPDX, and we mainly cared about licensing, IP, and who the authors were, and any other proprietary information that were part of the SBOM. But yeah, we generated in both formats. Yeah.
And you're generating it from the container image?
Yes, that's correct. Yes. Oh, sorry. Once again. This one. This one.
So we are doing one scanning, like we are running some express scan.
Uh huh.
We are entering the artifactory. So what kind of checks are done there and in the next step?
Yeah, I can talk about that. So at the so you see that orchestrator level, right? Jenkins level. So before that, we do SAS scan, DAS scan, and so on. Before we actually like publish the image to artifact to the content registry. Here we used Artifactory, but yeah, we do. Sorry. We do a SAST, SEA, and a DAS scan at that level, and then once it comes to the deployment orchestrator, we had some rules written in a language called Rego, where we had like we had our own like internal REST API call service that we hosted in like AWS API gateway that we could query, and then on the background it would run those Rego rules, and then check if like those rules are satisfied. Like one of them would be like a very simple rule would be if you're trying to deploy something, and it would actually go and check Jira if like it got an approval from the product manager or something like that.
Which kind of tools were used in like both of the steps? Like for the SaaS scan, were you using something open source or was it like something?
It was a mix of both actually, because we were on this journey of like trying to get to this place. We were strategically using tools that worked well with each other, but we were always open to swap them out in case we find something better. Like for example, like if you take this entire service by itself, we initially wrote it internally, but then later we found that there were better tools out there in the market that we could swap it with. So it was a mixed bag actually, to be honest.
You mentioned like a large number of feature findings.
Yeah.
Since you're dealing with a lot of like container-based deployment,
Yeah.
you need to kind of harden as well as standardize on the container-based images. But also because with scanning, a lot of the time
Yeah.
you get findings on the base image.
Correct. So there was a dedicated team that actually worked on generating base images. So and then the thumb rule was you should only use the signed base images that were given by that team. There were very few exceptions where sometimes internally the company might be directly contributing to open source and they might use a public image that they cared about. But I think the standard thumb rule was to use base images. But the base images themselves can, but again, right, like all that, I'm just telling there is a thumb rule right now, but then this was more of like a organizational journey where you had to like set up workshops, tell people that hey, this is how something has to be implemented, and then it takes a while for it to actually get buy-in and get rolled over to all teams.
Like this is a very obvious question for a topic like this.
Yeah.
Dealing with like false positives and reducing them down and then communicating with the vendor perspectively so that they don't get affected.
Oh yeah. Oh, how did I manage false positives? I think the most honest answer to that question is, once we came up with a framework like this, it was very eye-opening for us. That's kind of like the hook to the entire talk title as well, right? So once we ended up doing this framework, we were like, oh, it has 100K violation. I mean, I just added 100K in the title, but then there were more than 100K actually. Like the tool that we were using, it just mentions 100K plus something, right? So we were like, well, we'll worry about false positives eventually, but then there are like a lot of other issues that we should first target. So we can, to be very honest, we didn't get to false positives, but then the one thing that we were mindful of in terms of like false positives, where we cared about like if we made a call, we should really care about the CV or not, right? Because there were investigations like the point I previously mentioned, right? Like all CVs are not vulnerable. So should I care about this or not is a call that we used to have like a macro sprint plan where we sort of like went over some top vulnerabilities that we should probably care about and what we should not care about. That was probably like a quick litmus test into false positives, but that I wouldn't say that's an entire solution by itself, because they were like bigger fish for us to fry in terms of like actually fixing things. But then I think we'll eventually get there. Yeah. Thank you so much for asking all the questions. Thanks.